welcome to another episode of Let's Make It. And as you can tell, this week is going to be just a little bit different because this week I'm actually traveling. But I have something that I want to show you that I got from a Kickstarter. I think it was a Kickstarter campaign that I have mentioned in the past. And I also want to go back. I've had a lot of questions about the ADSB episode about 2 weeks ago. And I want to cover some things with that and kind of show you what is possible with it from the area that I'm in when I have it outside in my shed. So, but first of all, I want to thank everybody for tuning in and telling your friends. I'm just amazed every week at how much this show grows, and the amount of email and comments that we get is just awesome, and I would love it. I mean, our goal here is to help you to learn and to teach and to share what we have fun doing, and I really appreciate all the great comments that we get from everybody. All right, so this is going to be a fairly quick week because, like I said, I'm traveling. I have all the nice lights. I'm in a hotel room, and it just isn't the best environment to do a show in. But what I do want to do is to go over this thing called MicroPython, and it was a Kickstarter project, and it's a tiny little board that runs Python 3, I think, Python 3. And it's really easy. Basically, you plug it into your computer, and it shows up as a hard drive, and you edit the files right on the device itself. There's no IDE required. There's no pushing. Basically, you edit it live on this little disk. It's on my Mac. It's called No Name, which is pretty common for a USB drive. Edit the main.py file, save it, restart it, and it just runs. So very quick, very easy. No software to install. It just works, and I've been pretty impressed with it so far. I'm still learning a little bit about it, but from knowing the Python language, it's actually very, very quick. And they got some nice libraries also that are included, so it makes it real nice and easy to get some certain things done. And I haven't tried them all out yet, but I'm just very impressed with this little board. Plus, it also has an accelerometer on it, and I'll actually show that in part of the show today of some tricks you can do with the accelerometer, with the lights that are on the board, just so you can see which way you're moving and things like that. Before we go too far here, let's go ahead and let's take a look at the board. So this is it, and it's a MicroPython, MicroPython, and it's micropython.org if you want to go look at it on the website. See, it's very tiny. I see. I don't know the exact number of I/O ports. Let me see on the back here if it says. It looks like 12 I/O ports. Some of them are they're GPIO, so they're general purpose. Some of them have controls for PWM. In fact, there's also an example on the website about using a servo. Very simple. I mean, a couple of lines and your servo is working. It's very simple to do in Python. But this is the board, and whenever you plug it in, let's go over here. And we're going to show you how it looks on my Mac. Right here, you see where it says No Name. That's the drive. And if I open it up, you see you have boot, and then you have main.py, a README, and the PYB CDC inf file. And if ever you mess it up, you can basically hit, there's a sequence you can do, and it'll recreate this drive exactly as it is. We're going to mess with the main.py file right here today. All right, so let me kind of get things set up here real quick, and you're going to hear a lot of clicking on the keyboard today. Okay, so this is our edit window. Let me get this little black thing out of the way down here. It's going to be in your way. Okay, so I have opened up the file, and you see right here it's volumes, and on the Mac it's No Name, and then main.py, and you see it comes up completely blank. And I'm going to paste in some code here that I don't know, all the Mrs. code today I've done separately, just so it was a little quicker to go through. So that's the code, and basically all this is going to do is I've defined that the LED variable is equal to the Python board LED library number 2, and I'm going to basically loop forever, and I'm going to toggle the LED. So instead of knowing if it's on or off to toggle it, it just has a toggle function, nice and clean way doing that. Then I'm going to wait for 1 minute, 1 second. So let me go ahead. I'm going to save this. Just like this, and then I have to unmount the drive in the Mac, otherwise it will complain. So let me do this. Oops, the wrong one. And let's go down here to No Name. I'm going to eject the drive. I think I'm going to eject the drive. There we go. And then I'm going to come over to the board, And on the board, let me go over to this camera. There is a reset. Let me see, reset. And then there's a user. So this is the user button right here. This is the reset button. So I'm going to hit reset. The other thing you're going to notice is there's LEDs on here, and they're very tiny LEDs. We'll see that more as we go forward. So I'm going to hit reset. And then there we go, our 1 second on. Is some lights on here. And you can see that the green one is blinking. That's our program that we just wrote. 1 second on, 1 second off. I can't figure what angle to go to. There we go. So you see there, the green one's blinking. All right, so that's a very simple one. Let's go out here and we're going to change the code slightly. So let's come back over here to the computer, and if I can get it over here. Okay, so we're at the computer. Now we're going to come back, and since we rebooted it, no name showed up again. So we're going to open up no name just like this, and we're going to edit the main.py. And I've been using Text Wrangler. So there's our program. And this time we're going to do a little bit of an array example. So we're going to, first of all, define our LEDs. Let me go down here and grab my code out of the notebook. Okay, there's this. So we're going to go ahead and get rid of all this right here and define our LEDs. Oops, I didn't get all the code. All right, I'm going to grab the rest of the code. There we go. So all we're doing here is we're defining an array of LEDs, and there's 4 LEDs on the board. Actually, there's 5 LEDs on the board, and I'm creating an array, and basically we're assigning the ID of LED for the number in the range of 1 through 5. So we're basically creating an array here of objects that point to LEDs 1 through 5. No, it's only 4. I'm sorry, there's only 4 here. 4 LEDs. 1 to 5. N equals 0 is we're starting our loop, and then we're going to do this forever again. So what we're going to do is add 1 to n to every loop, and then we're going to do a remainder operation and of 4. So we should go constantly be going. Well, even though the n number is always going up, it's always divisible by some point of 4 with a remainder. So it's going to go basically 1 through 4, or 0 through 3. So it'll end up being with a remainder. So then here we're going to just toggle the LEDs, and we're only going to wait 50 milliseconds. So this is going to be a very fast moving thing. So let's go ahead and we're going to save real quick. All right, there it's saved, and it takes a while to save, so just gotta make sure you watch the LED on it. I'm going to get out of this because I'm getting ready to eject this. So we're going to eject. All right, now we're going to go back over and we're going to look at the board before I reboot it. So now I'm going to take the board and I'm going to hit reset just like this. The disco effect and all the LEDs that are going across. So, and a lot of the code that I'm actually demonstrating here is actually can be found on their website as well. I've modified some of it a little bit just to do different things. But so if we go back over to the computer and we're going to go back into no name again, just like this. And go into Text Wrangler. So there's our code. Again, we just defined an array of the 4 LEDs, and we're going to loop forever. So while this is running, n's constantly increasing, and we're dividing it by 4, and whatever the remainder is the LED that we want to do, and we wait for 50 milliseconds. So you see that disco or walking effect, as some people will call it. All right, so let's see. Let's go and do something a little different here. Go get the code. So it's a very powerful board, and actually I'm going to, there's a switch on it as well, and I'm going to walk through that real quick just to show you how simple a switch is as well. And then maybe we can even do a little callback here. Let's do this. So I'm just going to change the code that I have on the screen. That'll actually make it easier. I'm actually just going to make LED equal to LED1. Get rid of this range. Don't need to do the range. So this is all coding on the fly. And then I'm going to do, I'm just going to say switch. And again, it's PYB, which is the Python board. And then this is another library that we have here. And there only is one switch, so you don't really have much of a choice as far as numbers go there. Let me get rid of, I don't need this. And basically, I'm going to do, make sure I got the switch correct. I think I do. And then I can show you a little thing about interrupts as well. All right, we're just going to do it this way. We're going to make it really simple. Not even going to put a condition statement on it. We're going to do, no, I'm sorry, I already defined it. LED. All right, so actually I was not going to use a condition statement, but I'm going to have to because there is no common function. So we're just going to do this. If switch, I think I can do it this way. If switch LED on, else LED off. Okay, so here is the code that we just did, and it's really simple. Just define LED, and it's time doing LED3, which I believe is the yellow LED, and I define a switch object, and I'm going to loop through this forever, basically, and checking the state of the switch. And if the switch is pressed, I'm going to turn the LED on, and if it's not, I'm going to turn the LED off. So I've already saved this and uploaded it. So let's go look at it. And the problem with these micro boards is they're micro. So here's the board, and this button right there, you can barely see it, is the user button. And when I press the user button, you see the yellow light comes on. Actually, it doesn't look yellow to you probably. It looks like it's green, I think. But it's yellow. And that's what that program does. It's all it's going to do. So now I really only want to go through one other thing. That's the accelerometer. I'm actually going to use the sample of the accelerometer code that came from them, because it's really quick to put in there. I don't need to go through all the details of it. But there is an accelerometer, and let me get over here to it. There's actually a very great tutorial also on the website as well. So I want the long one, so I'm going to just copy and paste it from their website, because it's a great example of how the accelerometer actually works. And if I could copy it, okay. All right, so let's come back over to the computer. Sorry about all the delaying here. It's really hard when you don't have the controller in front of you. We're going to take this code and we're going to replace it with their code off the website. And just like that, and we're going to save it. So it's saving right now. And then we'll walk through real quick while it's done saving. But basically, we're defining an array, or like they call them tuples of lights of two different LEDs in pairs. So here's the X and the Y, and we're setting our sensitivity to 3, because if you just did it on one, just a tiny bit of movement would make it go nuts. So we want a little bit of control over it. So we're going to do set the sensitivity, And basically what we're looking for here is the accelerometer returns an X and a Y value as far as how far it's moved since the last check. So if it's greater than we're going to assume we're moving, I think that's clockwise, or around, it would be somewhat clockwise. And this is the opposite direction. And then if it's not moving at all, we're going to turn off the LEDs. And it would be same with the y-axis as well. And there's also a z-axis, which we didn't even include in here. So let's go ahead. This is saved. And now let's hop back over to the unit itself. And I'm going to hit reset, which is right here. And then we're going to watch what it does. All right, so if I turn it this way, you see it's blue. If I turn it this way, and I don't know how else is going to translate in this camera, because this is not like a camera in the studio. So this way is yellow, this way is green, so this way is green, this way is yellow, this way is red, and I'm also turning it a little bit the other way, so it's showing up green. This way is blue. So you can see it knows what direction it's going for the accelerometer. So it's very cool that the accelerometer is built into this board. I can see a lot of uses for this for like model type things or any kind of movement. There is no GPS built into it, but otherwise it's pretty cool that the accelerometer is built into it, so you can see me changing directions. So that's the MicroPython. Now, last I checked, it still was not completely delivered out of Kickstarter yet. So they aren't, you can't like buy them yet, but it should be available very soon. There's the thing on the website you can, well, last time I looked at least, that you can get in line basically to get one. I think there's great potential for something this small, running simple Python scripts, no compiling, no IDE required. I mean, it's really a great thing. So the other thing I wanted to cover, since I have it kind of with me, at least I think I have it with me. Let me just make sure. Let me get out of all the windows here. One of the apparently the most popular episode as far as questions go is the ADSB airplane tracking thing, and I've gotten a lot of questions like, how well does it really work? I know we sell those on the website now, the little RF boxes. But what I wanted to do is I kind of wanted to show you. Let me see if I can do this quickly. I kind of wanted to show you what I see from where I live, which is in somewhat western Maryland. Let's see if I can get this up. I need to change my shot a little bit. I think this would be a good enough example. So let me go back over to the computer. I'll just remember to keep it over here. All right, so this is a map of what I see. I'm located, let's see, Maryland, somewhere in this area right here, because I'm like a mile or two from the state line of Virginia, and then another mile from West Virginia. So I'm like right there where they all three kind of meet, the tri-state. And this is an antenna that I showed you how to build on an episode back. This is a 12-segment ADSB antenna. And you can see I'm seeing the whole way down. Here's North Carolina, right? Here's the North Carolina border. So I'm seeing a plane the whole way into North Carolina. And I'm seeing things, out past the Pennsylvania line in West Virginia and well up into Pennsylvania. My easternly view is not as much because I have a hill in a house that's on that to the eastern side of me. So my view to the sky is I'm actually trying to get, I've already ordered, it hasn't been delivered yet, 5 segments of 5-foot antenna mast. So I'm going to stick it up another 25 feet to see how much that helps, because that should be pretty much at the top of the hill, I think. And I want to see how much farther east I can go. You can see right here, I saw this one was over in Delaware, but it seems to be when the planes are when they're high, that's 33,000 feet right here. I can see farther, but the ones that are coming into the Baltimore or Washington International Airport, I tend to lose because they're getting lower, where I can see most of the planes that are coming in to IAD, which is Dulles International, and I can see planes heading down the Potomac to head into National Airport as well. But I don't, when they get down into the river area, I start to lose them because they're a little bit lower, and that's easterly of me. But I can obviously have a good view south. I have a decent view west and a decent view north. So my east in this area up in here is where I really don't have a lot of view. But that's just one of them. Let me bring up another one. Did it change? Yeah, okay. So this is another time that you can see down in North Carolina, actually right here again, is a little different view, it's moved a little differently. But you can see I have quite a few planes in there as well. And it's interesting to remember that only about 17% of the U.S. planes have ADSB. They ought to all have them by 2020. So that's something interesting to remember. This was just a funny one. I was watching this little plane out of Dulles. Right here's Dulles. And it was just squiggly all over the place. I thought it was funny. Because this plane here is turning in. It's 3,900 feet, turning in to land at Dulles. So I got a good view of the Dulles, approach and everything. Let me see what other ones do I have. That's similar to the other one. I just thought it was funny, that little guy. So here's a different time. And you can see this is probably towards evening, because it seems like in the evening a lot of planes are heading this direction or this direction. In fact, there's a certain time of night when I see a ton of Federal Express and UPS planes. FedEx is heading, if I click on the plane and I track it, it's heading to Memphis, and then all the UPS ones are heading somewhere in Tennessee, I believe, if I remember correctly. But yeah, it's very interesting to watch all the planes. So anyways, gotten a lot of questions how well that works. I will tell you the little dongle comes with an antenna that is not so great. So that's why the ADSB, and it's cheap to make. I mean, it was probably under $10 worth of stuff to make it, and it was kind of fun to make. So if you're interested in watching airplanes, and we'll get more and more airplanes all the time, and this was actually the way I've been doing this particular one that you just watched, is I'm running dump 1090 on a Raspberry Pi, and it's out in my shed. So I have a Wi-Fi link to the shed now, and this is running on a PC, and it's called ADSB Sharp. I can't remember what it's called now, but this basically is another program running on the PC that uses the Raspberry Pi as the feed. So you can use that same Raspberry Pi to also send to other places that do plane tracking, and you can get free accounts on those plane tracking sites if you like to watch planes and stuff like that. It's very interesting. It's very fun, actually, and it runs all the time. And I'll check on it a couple times a day, and sometimes I'll just bring it up and just watch it, just because it's fun to watch. I've gotten a lot of questions about the ADSB and the antenna. There's other ones. Cars is another one. I haven't done that yet, but I'm probably going to do that very soon. And there's also one for AIS, which is for boats. So if you live close to the shore, you can see where ships are as well. So, and I put links to the software and everything I was using for this out in the show notes for this show. So I appreciate everybody kind of hanging in there. I know it's a little bit rough doing this in a hotel room. I don't have all the nice controls to jump back and forth real quick and things like that. But I appreciate you all hanging in there. And next Monday we should be back in the studio, and I believe Bob's with us next Monday as well, because I get back on Sunday. So I will see you all next Monday. For show notes for this show, contacts, and more, go to the techzen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.